Let's go live. Let's go live. Let's go live. I am live. It says I'm live. All right. It says we're live. So we're live, right? That's how we go with it here. Welcome to the stream. It's been, I don't know, it's been a couple of weeks, or it feels like a longer week because, not gonna lie, I feel like I've been on another planet the past couple of weeks. Um, to go from the rush of the automation world, go, 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 customers, all of that, to be able to actually get some vacation, to be able to come back. It's been pretty nice. Yeah. So if you are joining in live, thank you for it. If you're not familiar with who I am, my name is Jason Watts. I'm the CEO and founder of a little automation company out of the not South America, Southern U.S., Southern U.S., Alabama, and we've got a little bit of group of people that do their thing really well, and we service industries from light industrial, OEM, agriculture, and we do some mining work as well. I've got about 24 years of experience working in automation. Saif, nice to see you back, actually. It's good to see you back on stream. Missed you for most of the stream last time, so it's good to see you back. Saif is one of our uh, resident uh, chatters. I think he's been on most of the streams and constantly involved, and he's definitely been a part of the growth of this channel. We've been growing, kind of started taking it seriously, I don't know, probably about 8 months ago. And we've seen amazing growth with just becoming a part of this community and getting more and more people involved and getting them up to speed. If this is, again, kind of telling a little bit more about me, I got a little bit of advantage in early on in life. My dad got me involved in automation pretty early on. That's why I have about 24 years of experience and I'm only 38. Um, is because I started at when I was 14 working on this stuff. So don't feel bad if you feel like you're late to the game on this stuff. It's constantly changing. And yeah, this channel is designed to help you out, to get a leg up and to get going. Today, I don't think it's off topic or anything because the cool thing about automation is this channel has a lot about Siemens in it. Primarily Siemens. We do talk about other stuff, and we're going to be talking about some other stuff today. Specifically today, talking about these guys. Can you see those? Is it, yeah, Balluff and Balluff RFID. So this little guy here is it's a model BIS014L, something like that. I'd have to look behind my definitely a brick wall right here. But yeah, so this is an IO-Link, an IO-Link RFID module, and I just realized I don't have my data carriers. Sorry, have to give me a second. Yep. So, and we are going to be hooking this guy up to our little 1200 PLC rack, and we're going to be using our little data cards, data carriers, to kind of introduce some concepts to you, show you how to use. These are IO-Link, and so they make ProfiNet modules, which I have one, but I need to keep the stream relatively short today. And so we're going to go over the IO-Link module, because if you're not familiar with what IO-Link can give you, it's pretty cool. And so we're going to be talking about how to use an IFM ProfiNet to IO-Link gateway, and they're some pretty stinking cool devices. And IO-Link opens you up to a world of manufacturers, and what we will be talking about today will be able to be transferred kind of to anything that uses IO-Link. You'll be able to use these concepts, because one of the things about IO-Link is, especially the way we're going to be doing it, once you figure out how to set up, and let me mute that. I don't even have my stuff on, because that's not your Discord. That's my Discord. But yeah, so once you figure out how to set up your gateway, the IO-Link just is taken care of for you, and then you'll be able to use this same thought process that we're going to be going through today. You'll be able to use in yeah, any other device. So like barcode scanners, other we kind of talked about. I sent out a community post, just kind of like, hey, what do y'all want to do? What do y'all want to talk about this week? And so people were talking about some keyence devices and barcode scanners and stuff, and a lot of that stuff is on IO-Link, and IO-Link opens up this kind of common industrial protocol that has some pretty cool devices on it. And we will eventually go over the ProfiNet version of this, so you don't actually have to have the gateway. You just plug it into our little device. But yeah, so without much more, welcome to the stream. If this is the first time you've been on the stream, welcome. Drop where you're from in chat. We usually have an international community in here, and it's the one thing I love about working with Siemens is that international community. Even being from the South, I've traveled enough to realize that you can always learn from someone, and that's what we're trying to do today. And if you kind of like this stream, there's a lot of edited videos that kind of specifically go through topics. This is a little more free form on these live streams. And yeah, if you like what you see, like the stream in order to get it out there, but then also subscribe, because I try to do this every week. Past couple weeks I haven't been able to do it exactly every week, but yeah, we try to get these live streams. And if you join in chat, drop a comment, we try to have a user created content. So you are the content, you are what drives this channel, you are this community. So thank you for it. And yeah, let's get moving on to what we're doing today. So put the headphones on, and we will go from here. I don't know why that's not coming through my headphones. But get a little music going. Go from there. And again, if y'all are in chat, and the music's too loud or you can't hear it, whatever, like, feel free to just yell at me. Also, if I cover up something important on the screen with my face, yell at me in chat, because I do that a lot, and frankly, I don't realize it because I'm looking over here, and the view is over on this side of like actually what's getting shown on the screen. So yeah, you got to help me out. You got to help me out for sure. So what we're gonna first do is I'm gonna show you the IO-Link module, and I'm gonna show you kind of just stepping through, assuming that you don't really know very much about kind of using these type of devices in Portal, because there's for kind of Siemens veterans, you kind of take for granted the fact that, like, oh hey, the first time I did this was probably pretty early on in your career, and most of the time people will be using all Siemens equipment, but then that kind of limits you to some really cool stuff. So we're going to be talking about how to start from scratch, basically. And so we are looking at this guy today. We're going to be using this. And so this is IFM. And if you've never heard of IFM, apparently they're a German-based company. Something about these German companies in me, because we've got German, but yeah, so it is a very cool company that does kind of these communication gateways. We're going to be using this little device here called the AL1900, and just because I'm from Alabama does not mean that this is the only reason I use this AL1900. A little joke for the Southerners in the room, but yeah. So this is a ProfiNet gateway that connects in ProfiNet to our processor, and I've got one of these in a little rack that's sitting down on the floor. I probably need to get a longer cable, or I don't have enough plugs around my little desk here. Otherwise, I would show it to you. But it's down on the floor. I've got my little 1200 rack with a little power supply, little switch, network switch, and then one of these guys here, one of these AL1900s. And what we're going to be doing is we're going to be using a GSDML file, and that is going to be what is going to we're going to bring into our project. And so the first thing that you have to do is you have to have these files, and you're going to need, if you're using anything on ProfiNet, that is what's actually communicating to the PLC. Is this the device is communicating ProfiNet to the PLC. And so you'll see we have this Balluff device, but in our setup, you'll see that we don't actually have anything Balluff in our hardware configuration. We're going to be using this GSD file for this IFM ProfiNet interface. So again, I kind of am just going through. If you have questions, I will answer them. And even if they're a little bit off topic, it's not that big of a deal. We're here so that y'all can learn. And a lot of times, the questions that you're going to be asking are questions that wherever you are in your state of kind of your automation journey, anyone in that state is going to be having these same questions. So when you're first starting out, you might have questions about like how to connect to the software, how to like save programs and things like that. And then as you progress on, you're going to reach these different stages in your journey to where you're like, hey, this is new to me. So don't ever feel ashamed to ask, because that's one of the things that's like, if you never ask questions, you're never really going to learn, or you're really limiting what you're going to learn. So even if you think that everyone in the stream or everything on the stream, everybody on the stream would know it, please ask away anyway, because you'd be surprised. So we are going to be using this IO-Link master. And if you go to ifm.com, for us, it's US. If you just go to the ifm.com, it's an international website. And so pick your region and you'll get your languages and all of that. But find your device. For this, we're using these IO-Link master, the AL1900. And on the product page, go to downloads. And the way IFM does this is it gives you these, they called startup packages. And gotta cover that up. Sorry, I get distracted. Anybody that's been on the stream before knows that I get distracted. And one of the things that distracts me the most, like in the side of my eye, is the delay from the stream. And so I'll move something over on one screen and it distracts me in the other. I've got ADD. It's trouble. But so back to the startup packages, you have these different packages for these different ProfiNet, because you're picking ProfiNet. You have Ethernet IP versions of this, so anything that would be using cheers, Bilal, from Finland. Back on the stream. Welcome back. It's been a couple streams since I've seen you in chat. It's welcome to be back, or welcome back. But yeah, so we're talking specifically about ProfiNet devices today. So these are all the different devices that use ProfiNet. And so as you see here, you have your Siemens S7. So that's either Somatic Manager or TIA Portal. And then you have your PCS7, and then you have your FANUC series, Mitsubishi, KUKA, those, which it's interesting to note that like you have some of these robot providers that offer ProfiNet. Any ProfiNet device can use these GSDML files. They just have to be the correct version. These GSDML files that we will be talking about are vendor agnostic. So they don't care about what the vendor is. They just contain all of the information that vendor is going to need in order to connect to this ProfiNet device. So for us, I downloaded a while back this Siemens S7 in this Siemens S7 block. And you'll get a zip file, you unzip it, and it'll have a GSDML file, some manuals, like a little quick start guide, stuff like that. And so that's where you get this information. Same thing for the Balluff device. When we do the ProfiNet device, you're going to need a GSDML file for that Balluff ProfiNet device because, and yeah, it's back behind my definitely brick wall. And so, but same thing, you would go to Balluff's website, look up the device, go to downloads, and it would have the GSDML file on there. One thing also that if, and this is a little bit, if you don't have access to the internet and you only have access to the device itself, the devices actually have web servers built in, and you can download the GSDML file from the device itself and then put it into it just by using a web page. So bring up Chrome, Internet Explorer, Firefox, Safari, whatever you're using, and go to the default address of that device, and you'll be able to connect into it and download the GSDML file, and then go through the process that we're doing here. That's kind of like an advanced way of doing it. Hopefully, you're ahead of the game enough to where you're not out on site having to put these things in and connect them up. That you're actually going through and ahead of time getting everything together. So we have got, yes, yeah. So if that's a little known thing, anything, or I guess I say that it's based on the vendor. I know Balluff makes them available. IFM makes them available. Most of the vendors that have device configuration that's on the web page, that you can just hit the device, usually on the front page there'll be like a GSDML file that's available. So definitely in a pinch if you get into it, and it's definitely helpful. So get this downloaded and we'll go through and I'll show you a little. As you can see, I've got some other stuff here that we'll need to kind of go through in order to get this going, but we'll come back to this page. So we'll get TIA Portal opened up and we're going to start a new project. And I definitely went through yesterday just to make sure that all of this stuff works. So hopefully, and I got it working yesterday, hopefully I can go through that same process 2 days in a row. And I noticed something that we need to do, repeat and shuffle, and then we need to go and do something because we missed all of our music. Got really quiet. Let's do this, and then yeah, let's go. Okay, because if I don't have a little bit of music, I get distracted easier, get out of flow. Yeah, so you guys like that? Do y'all have to have music when you're going, or do you like to be completely silent? It seems like it's divided. If I don't have like a good beat going, I will. I don't know. It's like I get out of rhythm and my brain can't quite work right. But we are gonna go through and start up another project after coffee break. All right, so let's make a new project here. And obviously I had Portal started up behind the scenes. I don't have that good of a computer, but we're gonna do this RFID on 1200 live. That looks, I cannot not read that as RFI Dawn. Sorry. My weird brain. Whatever. So this is the Dawn project. Sorry. I'm sorry. I'm sorry, I'm weird. But yeah, so we get this going, and this shows you the fact that I don't actually have a tremendously good laptop. It hurts when it's running Portal, the streaming software, music, a couple of instances of Firefox windows. So, all right, so we got that. Yeah. All right. So let's go ahead and get moving. Let's add in our device. And this is going to be, we're going to add in our PLC first. And we've got a little CPU 1200 DC. And it is a 40 version 4.5. So again, we've gone over through all of this. This is your first time doing this sort of stuff. I've got a couple of edited videos that really talk about the basics of getting stuff pulled in and connected. We're going to go through those, but I'm not going to really talk about them. But I'll just kind of mention them as we go through. But there's an edited video if this is the first time you are starting up a PLC or starting up a project with a 1200 in it. Welcome to the world of Siemens. But yeah, there's videos out there. There's actually quite a bit more videos, and I've got a couple of videos, edited videos in the work that I'm wanting to do. I'm wanting to do the edited videos, have some fun with them like we did on the last one. We're not going to protect anything because, I mean, really, it's here in the floor. So we're just going to undo all of that just to make sure it doesn't cause us any problems. So this is in the device and networks view. We're going to go into network view this is kind of what we're going to do. Remember, number one rule, always change your device names, okay, to something good. Make sure also that you don't have underscores. I've said this many times before. If you're using ProfiNet, don't put an underscore in it because it changes. An underscore is an illegal ProfiNet character, and I don't know why Siemens by default puts underscores in the names of their devices. Siemens, tell me why. If someone knows why, let me know, because yeah, in Southern terms, it don't make no sense. It just ain't right. But yeah, so now we're going to go in and I'm going to show you how to import the GSDML file. Now I've already done this, but I'm going to show you how to do it because you have to have everything over in this hardware catalog. Let me move my face over to the other side that way. All right. So you want everything in this hardware catalog. Yeah, it's for me it's the bane of my existence, so that I can be annoyed by it all the time. Yeah, so you need everything in your hardware catalog, and when you bring everything into the hardware catalog over there, that's what we're about to do. So if I have it in here in other field devices, ProfiNet IO, I think it's gateways, maybe, I don't know. What's it under? I can't even remember what it's under now. So that's the other one. Here it is. IO. IFM electronics. I have that here. This AL1900. I already have that in. You're not going to have that in unless you've used this before. So what you have to do is you have to install that GSDML. So we're going to go up to options up at the very top of the screen. We're going to come down. We're going to click Manage General Station Description Files, GSD files. Now, so as you can see, I have a couple installed GSDs, and I have a couple, maybe they're not used yet. Yeah. So I have a couple installed, and it's not showing the IFM because reasons. But what you would do is, I'll show you this Balluff one because I actually have it extracted. So it should be somewhere in my downloads folder. So this ProfiNet GSDML file, it would be an extracted device, and it would then show the contents of the imported path. Okay. So when you open up the folder that has the GSD file in it, it will bring up this little thing that says content of imported path right here. And then you select, and then you would install. Now, I've already got that installed, and honestly, we're not even going to be using this one. But this is how you would do it. You would click install. It would run through its little thing, got the little dial, and then it would be available in your hardware catalog. Now, kind of like I showed you just a second ago, it might be difficult to find in your hardware catalog, but we're going to cancel out of this. But all other field devices, so like if you are importing a GSD file, it is going to show up in the other field devices. So all this other stuff up in here it's all Siemens devices. So Sirius Act, Dynamics, ident, which is the Siemens RFID system, Sirius safety technology, all of these up here, it's all Siemens. So if you do a non-Siemens device and you are installing it with a GSD file, it will always show up in other field devices. After that, good luck. The reason I say that is, like, last night it took me like 5 minutes to find. I had to go through every little one in order to find this like Balluff thing, and for somehow I missed it on the first time, and yeah, I probably got distracted by like something shiny on the side of the screen. So what we're gonna do, IO, not Balluff. Balluff is the other. We're gonna drag and drop this AL1900 in, and just like we would with a drive, we're gonna click on this to where it says not assigned, and we are gonna assign it to this controller. Now, one thing that we do want to do is click on this little show all address labels, just to bring up our ProfiNet addresses, the IP addresses, just to keep them in our minds, because we're going to do something here in a second to where we're going to use this online access, which my head is covering it up at this point. All right, so I'm going to swap back over to the other side. We're going to use this little tool here called online access, because remember, I have all this stuff sitting in the floor over here, and so we're actually going to get to use the hardware. And again, this is detailed out in this getting started, the getting started video, so I'm not going to go too much into it, but we're going to go into online access, and we're going to update our accessible devices for our Ethernet card. We've talked about this before. So I have a system, because Alpha, my company, we have projects that are all over the country, and we have these devices that we can connect to and securely, like, create secured VPN connections to these other devices so that we can hop on networks just as if they were like sitting in the floor like this. And those use the tap adapter. So if I were to want to try and search on one of those remote networks, I would have to connect up to my VPN first, and then I would be using my tap adapter. We kind of had a question a couple weeks ago about if you were connecting over Wi-Fi, you're going to have to use your Wi-Fi adapter here. So all of the different network options show up, and you can pull accessible devices on each one. So if you're connected to Wi-Fi, then you're going to be using your Wi-Fi adapter. I'm directly connected, and so you can see to where I have these devices, and this is because oops, I set them up yesterday. It's not going to quite look like this. What you will have is, if your 1200 is right out of the box, then your 1200 will just have a MAC address. Same with this AL1900. It'll just have a MAC address, no IP address, because this little tool isn't actually looking at IP addresses. It is looking at MAC addresses that are available on that flat network that you're doing. If you don't quite understand the network part of that, don't worry. Most people don't, and those that say they do probably are lying. But just know that this tool you don't have to be on the same subnet in order to see a device on this using this tool. Honestly, you don't even have to have an IP address set up, because these AL1900s out of the box, they're a 0000 IP address. So what we're going to do though is, first, you can see that this 1200 is set up, but what I'm going to do is just show you how you would set up this device. You would find it, click on the drop down box, go to online and diagnostics, and we're going to say consider. Oh, I must have double clicked on something wrong. So I'm just wanting to do online diagnostics, and it'll pull up this orange screen. And if you're familiar with Siemens, you know orange means online. If the screen you're in is online or orange, you're live, you're connected. So we're actually connected to this 1200 PLC. And we're going to go down to functions and click assign IP addresses. And if this was straight out of the box, these IP addresses would be set to zeros. And so you would need to set those and click assign IP address. Obviously, I set this up yesterday, so no problem on that. If you have multiple PLCs on your network, you might want to go through and go ahead and set the ProfiNet name. And so for this one, we have live 1200 PLC here. And so let's go ahead and change this to live 1200 PLC like this. And then assign name. Now, one of the things that we had a problem with, I can't do that because it's in, if you notice, when I tried to do that, it said the set command could not be executed down here at the bottom. I'm pretty sure that was because it was in run. Let's see if it'll accept it now. Maybe not. Why? So, let's see why. Reach and support this function. Huh, okay. That's the most helpful help file ever. Sometimes the help files are helpful, sometimes they're not. So what we're actually going to do now, since we want to wipe this processor new anyway. So you would have to assign the IP address that way. Let's go through and show you. You would do the same thing with the AL1900. So this is on the AL1900. You would have to go through and set the IP address here and set it up to whatever it is going to be here. Okay. So you're good there. Those are both set correctly. And now what we want to do is we want to save and download this configuration to our PLC. So while offline, we're going to download, click on the PLC in the device and networks and click download. We're going to select PNIE, show all compatible devices, start search. And so it'll start looking for things that we can download to. We see one here and we want to load it. And it'll go through and say, oh, I forgot this thing. I forgot something. This will take a little bit longer than it. So we're going to say continue without synchronization because we want to basically wipe clean this device. And I had been playing around with it yesterday, trying to figure some stuff out. And so we just want to start from fresh. From fresh, start fresh. Man, I'm like 99.9% English only speaking, and I still English is hard. So to all you guys that speak multiple languages fluently, kudos to you. Y'all are awesome. Just the fact that y'all are on this English speaking channel from other countries shows that, yeah, y'all got a leg up in life. In being able to communicate to different people. We get kind of spoiled here in the US, and I don't think a lot of us realize it. But let's see. All right, so we downloaded that. One thing I do want to change that I was kind of talking about that I forgot about. So I'm going to click on this and say properties, and go to in the left hand. I'm not blocking this, am I? All right, in the left hand little project, scroll down and find startup, and change this startup cycle to, instead of 60 seconds, change it to something like 10 seconds. So it's in milliseconds, so 10,000 milliseconds. And then save and do that download again, because what that startup is it will wait that period of time before it tries to kick it into run. And so if you're sitting there, you click load, it loads almost instantly and then sits there and waits for that long to start up, and by default it's 60 seconds. And so yeah, so we're gonna load and get that going. So start module, and we'll go online here and just check. We're gonna go online because I have that selected. Actually, there's nothing else to go online, but because I have that selected, when I click go online, it goes online with the PLC, and you can see that everything's happy. And so that AL1900, because it has the correct ProfiNet name and IP address, it's connected and communicating to this live 1200 PLC. So I want to go through and do something real quick because we did this online access. Let's update these accessible devices and see if that, yep. So when we did the download and overwrote without synchronization and all of that stuff, it updated that ProfiNet name to 1200 or live 1200 PLC. So there are other ways to kind of go out and do this. I prefer the way that always works, and the way that always works is go out ahead of time and set your IP addresses on the devices that you know you want to connect to, because sometimes these things are really easy. But if you're working, what if I had 5 AL1900s already connected up to a system? Which one is which? Unless I went ahead of time and wrote down the MAC addresses of these things, I'm not going to know which ones are which. And so the best way to do it is the same way that works every time. And a lot of times I'll get people that will get kind of like into a situation on a project, and it's like, well, I did it this way, and I'm like, that should work, but that's not how I do it, because I know this other way works. Like, this set of steps works, and find the way that works every time, and just do it that way. Even if it takes you a little bit longer up front, it'll save you a lot of that. One time it doesn't work, it'll save you a ton of headache. So coffee break, because we got green lights. We need to reward ourselves. And I also need to mute my phone. So let's see. So one thing that we have to do now is we've got our AL1900 communicating back and forth to the PLC, but the AL1900 is just a gateway. What we actually need to do is set up this guy. Obviously this is not hooked up to our 1900, right? So let's talk a little bit, since we're in here, about well, let's have a little discussion about IO-Link for a second. One thing, just so that we kind of understand the architecture of how everything is connected up to. So we have, as we have on the screen, we have our PLC that is communicating via ProfiNet to our AL1900, so our IFM device. So we are going to connect our RFID reader up to this device. And so that's where you would want to go through, and I always go through and check to make sure that checking the manual to make sure that there's no weird connections. But what I found is that because IO-Link is a standard in the hardware and software, the protocol layer and the hardware layer, this stuff, like the wiring, the colors in an A-coded connector always correspond to the same pins and the same numbers in an IO-Link device. And what that means is, let me grab, maybe not. Let's look at this. Let's swap over to this. So as you can see here on the top of this, you have these little Phoenix connectors. And so this allows you There are devices that directly connect up with the little M12 connector. Is that going to focus on that ever? No, apparently not. It's not going to focus on it. But you have these little M12 connectors that are standard on IO-Link. There are some devices that are field devices. This is for inside a cabinet that you can directly plug this into. I have a cable that is down here. I don't know if it's long enough to reach. Nope, it is not. But it's actually connected into the top of these devices. If you're not familiar with what an M12 connector is, you might not be familiar with these, and like, don't worry about it. These are very common in sensors, and you have a couple of different connector types. You have what are called A-coded, D-coded, and B-coded. So alpha, delta, bravo coded, for you phonetic military people. These are an A-coded cable, and what that means is on the inside of the cable itself, it's not going to focus. It's not going to focus, is it? Come on, focus on it. Anyway, on the inside of the cable, you have these little pins. And so an A-coded connector cannot connect up to a D-coded connector. Even though they're 4 pins, they're made to where they just physically interfere with each other and you can't plug them in. Which means you can have different wiring and color combinations. So on an A-coded cable, a 4-position A-coded cable, pin number 1 is always connected brown, pin number 2 is always connected to white, pin number 3 is always connected to blue, pin number 4 always connected to black, all the time. And that is a coding for sensors. And the great thing about it is that's a standard. Unless your manufacturer hates you and they don't want your business, they will adhere to this standard. Again, we talked about the fact that these are A-coded devices, and it just so happens to turn out that an A-coded device on this IO-Link, the pin numbers correspond to the pin numbers of these devices here. So you can see here, these are the ports for this AL1900 is an 8-port, so an 8-device gateway. And so there are 8 IO-Link ports and then 1 power connection. And the cool thing about these are pin number 1. What color do you think should connect up to pin 1? I'll give you a question. Give you a hint. It's in the coding of the cable. So pin 1 goes to pin 1. So brown to brown, or brown to 1, white 1, 3, same thing. Simple, but in my experience, the fact that is done that way is just heartwarming. and it is it just makes sense, but making sense isn't common sometimes in automation. But yeah, so brown, white, blue, black. Brown, white, blue, black, and they connect up and work. And so what I have here, and one of the things on this is we can go into the actual, so this is on Balluff's website. We'll go here. So Balluff's website, this is the device that we have, the BIS014J. It is the IO-Link with integrated processor. So this has everything it needs. It has the processor and the antenna, all for these things built into it. I downloaded the user manual, and weird thing about their user manuals, I know this manual says it's in German, but it also has English in the manual. Don't know why it only says that, but anyway, and I think that there are other versions, but this is that manual. It's just like halfway down through the manual, it starts the English version. So I don't know why they do that. But as we could see here, this this device wants to use pins 1, 4, and 3. And fortunately about this device is it's the same pinout. I mean, it's the standard IO-Link connections. So connect pin 1 to 1 and we're good to go. And so I'm gonna reach down here and connect this up. So, and I don't, nope, it's not long enough. Eventually I will get my act together to where you can see this stuff, because I don't think you can. Oh yeah, there you go, you can see. Oh, so, and what we will do here, I have my little cards. I'll show you what they look like when, so you can see the little yellow light comes up when there's a card present. And so you can't see on there, it says CP, so it means carrier present. And so that shows up there. Now, we've got this set up to where it's at least working. So we've got it powered and it's communicating to the module. Now, where at this point is the information going to? Well, it's not going anywhere, because these things, one way, if you're on this stream, and this stream originally was started really through drive technology and a drive channel, and so you might be familiar with the Siemens S120s. And so the Siemens S120 has a single control unit and then multiple motor modules. And so they have multiple telegrams. That same thought process is the way that this device works. So you have 8 options to bring in 8 memory areas for that data going back and forth. And so the way that we set that up is we click on the device, click the device view, or you could click on device view and then come into this little drop down box and click our AL1900. And over on this right hand side, I'm gonna close, well, I don't need to close up. Over here on this right hand side, we see the different ports. So we have port 1, port 2, port 3, port 4, all the way to port 8. So we are connected to port 1, but nothing is configured there. There's no address space coming into this device at this point. And so what we need to do is to add in a submodule. And you get a lot of different options here, and they can kind of be a little bit annoying, but, or not necessarily annoying, but you can kind of be a little bit overwhelmed. So a couple of the things that you might notice is there's digital, disabled. So there's like this digital only. It's not an IO-Link input. The thing about this IO-Link module is you can actually use the inputs, or the 2 extra pins. You can set them up to be used as just a digital input. So if you have like an e-stop or something that's just like sitting there, or like a start button, I mean, this would be very overkill. Well, actually it wouldn't be overkill. If you had other devices like this, you could just use one of your ports and set it up as a digital input or a digital output. So it's pretty cool. But one thing you notice is this disabled. There is this disabled. That is hard to say. There is this disabled function here. We're going to toss these into our, we can't make changes online. That is one thing that I forgot, because this screen's orange. We're going to click go offline. Now, the reason that little dialog box popped up is because I clicked up here. If I'd have just clicked here, it would have gone offline. And since that was the only thing that was online, we'd be good to go. But let's go through and toss these disabled into all of the slots that we don't want bothering us. And so we're just bringing this over into this. Now we want input and output, because the thing about these devices, these Balluff devices, is they have an integrated processor. And so you're going to need to have, eventually you might want to have two-way communication. And so if there was only input, and you were only ever going to want to bring it memory in, you could save the output space by setting it up only as input. But we are going to use an input and an output, and then plus this PQI. This PQI it's acyclic, but we'll worry about that. We'll talk about that later. You don't really need to know that at this point. That's how you would set up configuration, like one-time things. Whereas these inputs and outputs are going to be cyclic, just like a drive. Just like a drive telegram has the stuff that gets updated all the time. So like your standard telegram, or like in my case, I like to use the 111 and the 352 telegrams. Those telegrams, those get updated constantly. But then you have acyclic communication using like a DP, not a DP, like a data record read, which, by the way, if you have no idea what I'm talking about, I have videos on the other side of the channel. So if this is your first time hearing about them, go check them out. And hey, subscribe while you're at it so that you can get updated on new content coming in. But yeah, so this, you can kind of think of these just the same way as a telegram, and it creates this input and output addresses just the same way a telegram does. So, but as you can see here, there's a lot of different options. So which one do we choose? Well, because this is this could be a device like a switch, it could be an RFID reader, it could be a pressure transducer, it could be any number of device that is IO-Link compatible. So we have to go back to our manual here and look at this process data container section. And we need to figure out how long of a packet we need. So this says the BIS M-4XX-45 processes 10 bytes of input data. Okay, so 10 bytes. And then it also says, all right, this other type, the -072, processes 32 bytes. So depending on the type of device that you are using, depends on how big of an address area it's going to take up. So the 014 is this 045. So like the full part number for it is this 045 processor. So we need to bring in at least 10 bytes of data. So let's go back to Portal. And what are our options here? All right, so that one is not enough because it's 8 inputs, 8 outputs. And so the next option is 1616. Okay, so that's not ideal. We're kind of wasting 6 bytes of data, and as a Siemens programmer, that should bother you, right? But for the time being, it's not going to be a big deal, especially for this. So we're going to drag that in, and we're going to take note of the fact that there are a couple of address areas that were created here. And if you notice, they don't line up. And that's because our I addresses and Q addresses line up in different areas. So if we could go through and line those up if we wanted to, we could go in to IO addresses and start them at the same place. In this case, the reason it started the input at a higher level or a higher offset was because that's been shifted. So we would want to start this at 68 to shift it back up. And why it doesn't end on the same thing, who knows? But we could do that, or we could just leave it as is. Either way, that just maps where it is in memory. But just always take a look at where it actually gets mapped in memory. One thing that can happen that I've kind of seen happen in the past is you go back in and you change stuff and you swap addresses, especially in these type systems. You've already created a tag and lined it up to an address, and then you go back in and change the hardware, and you're sitting there and you're like, okay, you don't realize that you delete two pieces of hardware and then you add them back in a different order. Well, guess what? Your tag didn't change. So your tag is still connected to the actual inputs and outputs, or the I addresses and the Q addresses. And so you just swapped the where your tag is pointing to, and you didn't realize it. So always, always, always set your hardware up first. Try to get as much hardware in working as possible before you start going into the next thing and adding tags, because those things will drive you crazy. Because imagine setting up a tag and thinking it's over here in the plant, and then all of a sudden it's responding to something in another side of the plant. Crazy thing about it is, if this same concept happens for the telegrams, and you go in and add in like a two G120s, and you're like, oh crap, I don't have the right, I'm upgrading these G120 CUs to a CU250S, where you delete them out of the project and then you add in CU250Ss, and you're like, oh, it's the same thing, I've got them set up. But you didn't realize that you added drive 1 in after drive 2 when you went through and reset them up. And all of a sudden, your HMI drive 1 is controlling drive 2, and drive 2 HMI is controlling drive 1 HMI, or drive 1. And you're like, what the crap? And all it was that your input and output addresses behind those tags got assigned to different areas right here. So yeah, but by the way, this happened recently and with a customer, and yeah, it will drive you insane. So always check your input and output addresses, and make sure that anytime you change hardware, you understand where you're pointing to. So what we're going to do now is we're going to save, and we're going to download this change, because what we got is now, hopefully it'll come up and we'll be able to get this going. So stop all, load all, transition. Wait 10 seconds. Start module. And let's go online. Let's see if we still got green lights. It looks like we've got green lights. So, and now we can go in here. Well, won't be here. It'll be here. Yep. So we're good to go. So we've got these 16 bytes here. So it starts, for right now, and probably for this whole stream, we're only going to talk about the inputs, and because we want to kind of work with them. So first thing you want to do in any of these projects is understand how the data is coming in. Okay. And so what we're going to do is we're going to go through, make sure I'm not covering anything up. We're going to go through and make a watch table. And so we're going to add a new watch table, and we're going to rename this watch table IO-Link ed. Okay. And all we're going to do is we're just going to make an address that's starting at this. So 68, and we want to go through 84. So these are bytes, right? And I guess we could, so we could go in, but the only way that we can, well, the easiest way to just make sure that stuff is working is by using a word. Let's just do IW, what was it? Oh, I have excellent memory. That was a whole 12 seconds ago, and I've forgotten it. 68. IW 68. And let's go through and keep adding these in. So 2, 4, 6, 8, 10, 12, 14, 16. So we need 6 more. Okay. Right. So that'll be 82, 83, and the next one will be 84. That is right. All right. So now we can go here and we can just monitor this. All right. And hopefully when we click on this, you can see I'm going through and you can see stuff's changing, right? Then we take our other one and it changes again, right? So one card, so we can at least see that it's changing, right? So it appears everything's working, and you can kind of start to see that, all right, maybe, sorry, this is about to fall off my desk. Stay. Hold on one second. I've got to fix this because otherwise it's going to fall off and hit me in the foot. Okay, here we go. So now I can do that. Wait. So, okay. So you can see, like, when I actually have the card on there, there's a value that's changing, that 81. So let's kind of go through and look and mess with a little bit here so that we understand, we can kind of start to understand how to look at this sort of stuff. So, and this also kind of goes in a little bit of how to read these types of manuals. So we have in this manual, so this is going through IO-Link basics, and we're wanting, it's talking about demand data. And let's go back 2 places. So here is the demand data, mapping of parameter data, but what we want is the process data, because that is the stuff that's getting updated all the time. This demand data, the way that it's being said is like, that's that acyclic. So you demand it and it comes back. So let's look at this process data. And we have 2 areas. So data exchange occurs via the process data, which, depending on the control system that is used, is mapped to the input, output buffer, and memory field. That's what we're talking about in our memory. So for the inputs, it starts at 68. And for the outputs, I think, 64 or something like that. So we are looking at our inputs, so our input words. Well, this is our output buffer. So let's scroll down and look and see if we can find our input buffer, which this is. And so now this is the structure of that communication coming back. So in this case, we have, so these are bytes. So these are 8 bits in a byte. So each one of these bytes, so we should have 10 of them, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So we have 10 bytes. This describes to you what everything is. So in our first byte, just like in a drive, in like a status word, you have that status word. You have a bunch of bits that mean stuff, and it's the same thing here. So we look here, the first bit is actually this CP. So code tag present. So the data carrier is in the read range of the read write head. And that's what's changing when when that little yellow light comes on. That's that thing that's changing. The other thing is the bit that's always on that makes that 8 is this BB, which is power. The device is ready if it's on. So let's take a look at this because I want to show you. And a lot of you will probably already kind of know this sort of stuff because this is a little bit of kind of the embedded system talk that we talked about, which we talked about it a good bit in a live stream of just kind of, it's an introduction to digital logic. And so if this is the first time you're hearing this sort of stuff, maybe you might want to go back and rewatch that live stream because it goes into a lot more detail about this sort of like the stuff we're talking about. But here we know that first word is going to contain this information. Now again, a word is 2 bytes, so we're kind of like compressing data in all of this. But let's change this display format to binary and move this out a little bit. Now I'm going to take this data card and put it on here, and so you should see that one of these bits changing as I'm like putting it on, and you see here, and tying it back into, this is the first byte is the most significant byte, and that's very important to think about because we're going to see here in a second, you can't always take that for granted. So the most significant byte is the first byte in these words. So as I remove it, there's bit 0, put it on, there's bit 0, on, off, and then power is ready, the device is ready, and so that's why that bit 8 is on. So why is that important? Okay, well, let's go back to the manual real quick and look at what this, because we're looking at words. This second byte, so let me do this. Let me pull this down onto this screen. Let me draw a little bit. Page width. And then we're going to do sketchpad. Right? All right, so this is IW68. Okay, and it might make sense that this is the most significant byte, and then this is the least significant byte, right? So that kind of makes sense. First in, first, like, is what you put kind of in this order up here on the screen. Well, if we are looking at something drink your coffee, kids. Don't breathe it. Hold on. All right, I will live. You can breathe at least a whole cup of coffee. No, you can't breathe any coffee. Breathing coffee is bad. But we're talking about the fact that that this is the most significant bit, and the most significant byte is the first that comes in, and the least significant byte is the second that comes in. So if we were looking at this in terms of words, these two would be word IW, so 68, 69, so this would be IW 70. This would be IW 72, right? So we keep going through here, 74, and then this is going to be 76, right? Or am I completely off? Yeah, that's right. So if you notice, we have 74. So the last bit of actual input data is 76. Well, aren't we getting back? Isn't 82 the last word in it? Yeah, because remember we had 16 bytes that we had to set up because of the GSD. That GSD file didn't have a 10 byte address area. So we have some extra stuff, right? Well, the problem with some of this is, and the reason I'm kind of like going through, taking a look, especially the first time that you go through and do this sort of stuff, and you're working with a new piece of equipment or a new sensor or something, you really need to understand the structure of the data, because sometimes you can't just change the way you look at something. So let's go back to our let's go back to this. All right, and I can go through and I can call up so we can see here that this and this are apparently being used by something. So apparently this card is using 2 full words of data, right? Well, if I wanted to, I could insert a row and I could call this ID for double word, and then call that 70. And then it actually will smush together both of these into one instance. Okay. And in this case, it doesn't really matter because this data carrier just carries a serial number. Okay. It's just a serial number. And these, I don't even know if these are writable. And so these just have a serial number on them, and it's a really big serial number, and apparently Balluff, because these are Balluff cards. And so apparently they just have individual serial numbers. So if we look at this, and let's just swap these over to something that kind of makes sense in our brain. Because I'll show you something. These are not the same number when you look at them versus an individual word versus a double word. So like in decimal, this is 945,000. If you're looking at just single words, you have two different areas, and that might make sense. And if you've ever used this sort of stuff, you're like, duh, Jason, why are you saying this? It's not quite intuitive at first. And if you go back to, I'm going to go back to this manual. Well, I'll just pull it up here. Problem is with the output data, start address, the low byte is in front of the high byte. So when you're actually trying to write this stuff, you're using 2 bytes, but then they're actually in the wrong order. So when you look at them as a word, so this, if you started off with this low byte here, go back and kind of just like stick this like this. This low byte would actually be the high byte in this. If you called IW, in this case, whatever it would be, 64 starting, so 64, 5, 6. So if you called and just wrote something to the byte IW 64, 5, 6, so 66, or sorry, QW. If you wrote to QW 66 in our case, and you just wrote, say, like a double integer, and you had that number, and then you transferred it and then you read it on the other side, it would not read the same number, because you're transferring, when you transfer it in and transfer it out, the bytes get swapped, because this is going to be the low byte. Sorry. So the low byte of that address, it's not going to make sense because what you're trying to write to has been byte swapped. We've talked about byte swapping in drives, and this is another instance of that. So just be wary, and as you're kind of going through, you're going to probably either write function blocks or stuff to do the things that you want to do for these. And so swapping some bytes around really is just a matter of like, hey, put like in your static data, if you do like an override or something, just name them, and then you're just swapping stuff around. It's not too terrible of a thing, but just make a note of it. And I've talked about that a lot, because that will, again, kind of like the whole memory address swapping thing, this sort of stuff will confuse you to no end if someone doesn't be like, hey, are those bytes in the same order, or high byte, low byte sort of thing. So that's why I bring it up, trying to avoid a little bit of headache. But yeah, so next thing I want to do is let's see if we can come up with a because all we're really wanting to do is make a serial number out of this, because the way that I intended for us to use these cards were to actually go through and say, all right, I have a piece of equipment that has a bunch of settings and a bunch of like set points and all sorts of stuff. I want to have a card that I can give the manager and say, hey, if this is tied in system to you, this is your card. You have the ability to unlock these set points and monitor these set points. And so what happens is every individual person has a card. Well, of course, if you use passwords on something, anybody who's ever been in industry knows that the first thing that happens with a password is the password gets written right over the top of the HMI. And so everybody has access to it. Everybody has, like, nobody knows who's actually using it. Well, with a card, you can, of course, the manager be like, okay, here's my card. Well, at that point, it's saying, hey, it was your card. It's your responsibility, the changes that are being made. Then that's a little bit different, because it's like the manager might be able to say, oh, well, I gave it to Billy Bob down here and he went and changed it. And Billy Bob's like, no, I didn't. He's like, well, you used your card, so you're the one getting the reprimand. And another thing is that I can have kind of like an unlock all card for me that's in my pocket, and I can come in and put this card in place and can drop it in place. It unlocks everything that I need in order to start up, because I mean, if I mess something up, it's my equipment. I'm responsible for it anyway. So yeah, so that's eventually what we're going to develop, that type of system for this in our little project here. But so for that, what we'd like to do is to, you know, bring in this data that we have coming in. So we have this data coming in here, and I want to go through and make a UDT or a PLC data type that encompasses this tag. And I want to make a tag and point it at it and then get data out of it, right? Because that's what we like to do. So we're going to go through now, and let's make a new PLC data type. And let's name this thing. Yeah, let's do this offline so that we can actually do it. Balluff. Let's just do this. Then what's the name of this? So let's just naming this something intelligent. So we're gonna do a 42. What is this? An M. Want this? I'm gonna name this data type. Okay. Whoops. I need to name this. Right. So we know that we're going to need 10 words, right? But we also are going to need that first control word and that last. So one of the things I didn't tell you about, we'll talk about it later, but there's like a little bit of handshaking that's going on. So this is the same. Dash status word. So this is just one byte, right? And so this is just going to be a bunch of booleans. Let's do this, booleans. Element 1. We'll do bool 1, 2, 3, 4, 5, 6, 7, 8. Is that enough? Okay. So we're going to go through this, and then now let's make our control words, right? Or status words, I should say. Let's get these pulled up. And this is for inputs. And again, we're not going to do this, but we're going to talk about the acyclic portion of it. But you would want to create these PLC data types. Again, I can't stress enough how much these UDTs and PLC data types will save you. It's going to save you tons of stuff. So 0, we're going to go 0. So that's this right here. Let's do this so that I can not have to. So bottom, this is CP, code tag present, job accepted, job so AF. Okay. Job error, and then we skip one in A. This is your first time to stream, and you hear the music. My brother-in-law, he makes the beats. Pretty talented. Got just a little simple little groove. So toggle bit. But yeah. Go through all these toggle bits. So head, failure, and power. Okay. So those are the control words. I'll save those. So now we're going to go up here to our other data type. And the first one is going to be a BAL. Right? So we're going to call this status. And yeah, so if this is the first time, so this is going to be status 1 because you'll notice the other has a status as well. And so now we're going to put these in. So error code, these are going to be in bytes. And it's not going to be this. So what I'm doing here is the way that all right, and so now so this, if you're not familiar with what I did here, creating this, I created this data type, and when you call that up, that data type, it gives you that tag structure. And in some places it's actually called structures. So like in the C programming language, if you're familiar with it, it's called a structure. Some places they call them UDTs, user defined types. Call these PLC data types because I mean they're the same thing. Same thing. UDT structures, kind of PLC data types, all the same. So now that we got all of that, we want our error code. And now this is the data that we are wanting to use in Word form, or actually, if we remember correctly, right? So this IO-Link head, when we went online with this, what was actually being modified? There. 70, yeah. So let's just do a double word at 70, which would be starting at the 4th byte, or not 4th byte, 3rd byte. So first and second byte are here, 3rd and 4th byte would be 70, you know? And then, so yeah, let's do it that way. Let's just do a double integer in our data type, because, and again, you get to customize this. You get to customize this by, because you know how you're going to use it. And someone else that's using this stuff, T-Ferg, don't talk about the forbidden software. Yeah, so it's UDTs. It's UDTs lots of places. User-defined types. It's not just in the forbidden software. But yeah, so I will answer your question about the V90 here in a second, because that kind of comes up here in a second. But yeah, so remember, in these PLC data types, when you are describing or you're designing them, you know how you're going to use them. Now, the guy down the street, if you notice, like in this, this could be data or the low byte of the version. So depending on how it's being used, could actually matter. And in our case, if we look at this, let's look at everything in binary and see what actually changes. Just real quick, just to make sure that we understand. So that changes there, and then swap tags. So yeah, so this full top byte here is getting used, so it is being used as the data. So this, like, this second byte, the second byte of the first word, is being used as this error code. So, and that's just the default settings. So I'm sure that there might be some settings that would be in here to where you have this high byte version, low byte version. But the way that it is out of the box is that this IW7, 7D, or the 3rd and 4th bytes are data. So because we know how this is set up, we're going to set up our UDT as, not that one. We're going to set up this as just being a double word, or a double integer. So we're going to call it data, and it is going to be a dent. Actually, can we do a double unsigned? I guess it'd be an unsigned dent. Yeah, because I don't think that's going to have a, no, Semantic Manager is perfectly fine. Semantic Manager is great. We're talking about the other software package in the US that most PLC programs in the US are written on. Alan Bradley. So whatever version of the forbidden software shall not be discussed. It shall not be named on this channel. I joke, obviously, but I have a lot of experience with Siemens, and I joke around about when here in the US, I'm the weird one because I use Siemens. And so I like to joke around about, it's like, oh yeah, Siemens programmers can tell an Alan Bradley programmer programming in Siemens for the first time. There's secret ways. But yeah, T Ferg and I work on different stuff. And so he jokes around. He uses the forbidden software. So all right, so we've got our data here, and honestly, so we've got to take up these because there's another status word down at this end. So this last byte is the second string. So let's just suck up a couple of, like, because we're not going to be using the data, but it takes up space in the telegram. So we have to kind of suck up some extra bytes. We'll just call it spare byte, right? And we're gonna do just a byte, and then we're gonna drag. So we've got an unsigned. So we've got this one, this one, this one, this one, this one, this one. So we need 1, 2, 3 bytes. 1, 2, 3 bytes. And then we're going to do a status 2. And we're going to do the val. Same thing. So one thing about this, if you notice, these two, it's a little bit of error checking. So the status words have to match in order for you to accept the data, right? So that's what we're trying to do here. So now that we have this and we've saved that, let's go through and let's download these data types so we get these Pepsi signs out of here. No one should drink Pepsi. I'm from Atlanta. You don't drink Pepsi in Atlanta. And if you're not from the US, you probably don't understand anything that I'm talking about. Coca-Cola headquarters is in Atlanta for everyone that doesn't make sense. So Pepsi is bad. And if you're still confused, it's because of these little symbols that we're saying that there is mismatch. Here in the US, we call them Pepsi symbols. So we've got those, everything's green. So now we can go in and let's make a tag, all right? In our default tag table, let's call it our card data. And hopefully, I did not do this yesterday. I was like, oh, I've done this a couple times. So I've done this lots and lots of times. So I know what I'm doing. So in this one. And so this should have all of our stuff, including our 2 status words, blah, 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 all of that. And so please don't make me a liar. Please work. Let's point this to our I68.0. And the reason it has to be I68.0 is because the first actual reference in that tag is a Boolean. So I68.0. So let's see, does it work? Let's see, does it work? Does it work? All right, that toggles. The error code is not toggling, which is fine. Hours on, code tag present. Let's try the other tag. It changed. Yay! So, awesome. So, I'm glad that I actually look like I know what I'm doing. So let's go through and I'm going to answer a couple questions in chat. So, because I have a couple people that asked about how to read some stuff from a V90 servo. So the drive motor current parameter, there's 2 ways to do this. There's one, if it is available to be put into a telegram, in like a custom telegram, then you would be able to assign that into a custom telegram. And I have a live stream where we did that, and talk a lot about making custom telegrams. If you'll take the time to look up that video, it is in the live stream section. It talks about custom telegrams. The second way, sometimes R values, which motor current I think would show up. R27, I believe, is available. Actually, your motor current is going to be in a lot of your standard telegrams, so you're not even going to have to use a custom telegram, because, for example, like a Siemens, I know a Siemens 352 telegram has motor current in it. It is just one of the words in your telegram. So when you set up your telegram, which is in a lot of the streams where we talked about in that custom telegram as well, to where how you do what we're doing here is going through and making a data type, so a PLC data type, to where it kind of takes out and sets it up. So you're going to make a telegram and either pick a telegram or make a telegram and then set up a data type or import a data type, depending on the situation. And it will be in that. If for motor current, that definitely will work. So definitely check out that in the custom data types live stream. And I think there's a couple of other edited videos that's about that. There's plenty of stuff out there. There are some what's it called, R values that are not available for cyclic communication, and those you need to use what's called acyclic communication. And you can use a block called Sina para S, and it is available in the it's actually available in the libraries. Let me move my head so you can actually see it. Here, yeah. So not this, sorry. So if we go to a program block and open up something, there will be an instruction. I'll show you where this would be available. So in optional packages, if you have Synamics here, yeah, so if you have Synamics, use this Sina para S, and this one is fairly straightforward. Toss this in. Yeah, that's whatever. This access number is for a B90, it would be 1. Hardware ID would be whatever your ProfiNet hardware ID would be. And then you can kind of see here, if you're just reading, leave this as 0, set this as start to update it. That's when it actually executes the read. And yeah, parameter, index, and then you're not going to use it right. So use this block for any other value that you can't put into a telegram. So we have another question, which, by the way, thank you so much for joining from all around the globe. We have some more people coming in. If this is your first time joining the stream, be sure to like the stream just to get it out there. We've got a very international community here that answer questions. We stay on topic, but try to stay on topic, but this whole thing is for you guys, and it's to answer your questions. And so we've been talking about Balluff RFID sensors, and we're kind of getting to a point to where we're closing up, but we also have some more questions about drives, which I always love drives. And so I'll say, so talking about MQTT, and if MQTT is not familiar to you, it is a communication protocol specifically for IoT devices, so Internet of Things devices. And MQTT is a secured way to communicate to these devices. It's a standard protocol, and there is a library called MQTT something that is absolutely available. Let me see if I can look it up. because we've actually done some testing with this library, and on a 1500, I think it's available after like version 2.x. I know it is, the MQTT library is not available on the version 1. And so yeah, I'm just looking up real quick here. And yes, so we'll drop this over here. So here is your MQTT, and I will copy this over into chat. And this is, again, if you're watching this on demand, I mean, I guess I have chat replay done. So this is the page that I have pulled up for MQTT, and it has a download for the library. Archive if you're like MQTT publisher, blah, 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 blah. Yeah, and this is a very good documentation for this example. And if I remember correctly, and again, I've kind of gone through this, there's there's a little bit, you create an MQTT. Yeah, so if you have an MQTT server and you're trying to pull data from it, you'll use the client. And if you're creating an MQTT server on your 1500, this would be, you would use the actual broker function. So the MQTT broker. And you'd be publishing these tags. So that might be something that we could go through later, because I think this 1200 is available, but this is the documentation for it. There is a version 16 example project in this document. And again, what you're going to be doing is you're going to be importing your client and publisher function blocks, and then just using and executing them according to this document here. It definitely steps through every step of the way on this. This is a very, very deep deep document, but as you probably have seen, if you've worked with MQTT, there's a lot of little bitty points and little things that like SSL certificates that you have to kind of like link up and get done beforehand. And so yeah, this is the where to start. When we did this, I did it about 2 years ago, and I remember that it was a little bit to get set up ahead of time, but once you get it set up, that's where you're going to be able to kind of like go from there. So if you're not familiar with MQTT, that's what this is. But yeah, I would start from there and kind of comment on this on demand. If you kind of comment on the on demand version of this, and maybe we'll be able to help you out on stuff like that. So we have got to the point in the live stream now where we're kind of coming back to our RFID, and we're almost 2 hours in, and I'm kind of needing to finish up. I've got to catch up because everybody knows about what happens when you go on vacation and you're an automation engineer. You just have to do all that work when you get back. So I'm going to be running around for the next couple of days for sure, trying to catch up. But I wanted to talk about a little bit of the last things of how we would use this. I kind of mentioned it before, how we would use this kind of like authorization tactic. Well, with this default tag table, now I can sit here and create based on I don't have to be able to write to this tag. If these have unique tag or serial numbers, and this data is unique to it, then I I don't really need to have, I'm realizing something though, that I missed on my bytes. So, you didn't tell me that. You don't tell me I messed up. I'm joking. That's my responsibility. So, I must have counted off or not counted correctly, because it looks like our bytes are actually coming in a little bit quicker than I need. So, because I've noticed this, I'll show you how you can go back through, and the great thing about using this like concept of like UDTs. So I realized that I made my UDT too large, because this is not connected to the second status, right? So let's correct that. So let's go back here to this one, and honestly we just need to delete these two, because spare byte 1 is actually where we need to do. So save, download this new, and it should do a consistent, yeah, I say that, yeah, consistent. And then let's go back to our tag table, go back online once it finishes. So all I did was just deleted out those two little bytes, and you see it automatically updates, and hopefully the tag is still pointed to the same place, so it's not working. So what did I do? What did I break? Did I put it to the wrong place again? Looks like I did. Byte. That's weird. What happened with that? So we put those in. I wonder that's happening. Let's put those back in. So that's weird. You know, troubleshooting, you see something like this. What's going on? So you kind of go back and undo what we just did. And maybe I took out too much. Go back to my default tag table. It's online. And yeah, so that works. That works with it at spare byte. So it needs to be in that spare byte slot. That's odd. So maybe let's just try it one more time. I don't know what happened there. It should be, we want this lined up. Maybe it's the fact that, let's take these and move these down below. Like that. I don't know why that would work. Don't ask me why that would be it. If this is it, then we're all confused. But I don't know. Maybe I'll figure it out later. So let's go back to our, and you can see the value in. It's obviously not, because it's not on. Huh. 78.0 70. Oh, it's not. 72. It's not starting in the right place. IB. Yeah, why is that starting in the wrong place? That's what's happening. Oh, because it's by word. Oh, that's interesting. Okay, I see what's happening. So what's happening is, and I don't know why this is this way. Maybe this is something that is just a restriction of Portal. I'm not sure, but this byte it's not allowing, this is not allowing it to fall in at the next byte. So a byte is this number here should be I-78, or sorry, I-77. So like when I put, for example, like when I do this and I move these here, it's saying, all right, byte, byte, byte. It's allowing it to be in the right space. So when I download this, it's actually, it actually allows this to be in space 77, and that's why, so it's in byte 77 there, and that's why this is working, because it's at byte 77, which is interesting. But anyway, so 68, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 10. So yeah, so 77, that is the last place. I don't know why it's like that. So probably what we actually need to do is modify, we would have to go in and make a second type. So like a second control type like this. Okay. So let's do this real quick and make it right. I told y'all that I needed to leave, and then I'm like, oh no, never mind. We're gonna keep going. I like doing this sort of stuff. All right, so let me move my face. Y'all, yell at me if my face is in the way. So we need to make a new PLC data type with, and I'll show you what. So this is going to be, so this is status word. I'm going to copy this, copy, and then paste. Why I did it that way, who knows? Status word, we'll call it E. We're not, all right, we'll just call it _1, since, let's go offline real quick. Status word E, and what we're going to have to do, and this will work. We're going to open this up. Now we're going to go in and we're going to insert row above this, and we're going to add in a spare byte, and it's going to be a byte, because we need a memory space that it allows for us to put in here. Okay, so now in our other value here, we need to change this to the E, the ending version, and then we're going to delete all of these. Okay, we're going to save that, and now we're going to download. It's going to work. It's going to work. Watch it. It's going to work. I hope it works. Have confidence. You know, I have confidence it's gonna work. So we've got this stuff here, and maybe is it gonna work? Is it gonna work? Spare byte. Yeah, it works. Of course it works, guys, right? See there. I knew it was gonna work. So what was going on there is, for some reason, I mean, and this makes sense, because in a PLC, everything is organized by words, okay? And in Siemens PLCs, it's a 16-bit word, so it's 2 bytes per word. In the forbidden PLC version, they are actually 32-bit words, so like the minimum you can like break it up into is 32 bits, so 4 bytes. And so when you call a byte and a byte, it would allow you to put them next to each other. But it did not know how to put something that was not a byte next to another byte. So it was just saying, okay, I'm going to address in the next word, which left a gap, and that gap is what we needed. So I went through and made this other user-defined type that made that gap for us by putting a byte in front of our booleans. And so now this user-defined type takes up a whole word, and it puts the bits in the right place and lines up these tags here where it actually needs to be. And so that's why it works now. Totally planned so that we could go through all that. Sure. So we were, I was kind of talking about how you would want to use this sort of thing in your PLC code, right? So our code, we could go in now, we can delete that. And if we wanted to like take, and just like do a move block, all right? Just, and I'm going to, so we have this tag now called card1 data. And if I want to move the data into like a temp, I'm going to name this, and it doesn't like that temp. And this is just so I can like, and it needs to be a udent. So card1 data, that's a tag. We can use all of that, right? We're gonna do a consistent download. See, this is Pepsi. Pepsi is bad, right? Don't want Pepsi. Don't drink Pepsi. Drink Coca-Cola. Coke Zero, preferably. Who needs all that sugar? But yeah, so now we have, all right, here's our temp data. Here's our actual data. And so that's a serial number of this card in the bag. And then here's the serial number for the card, this other card. And so now I can be like, also, I can go, so card data 1 dot status 1 dot code tag present, right? And card data 1 status 2 code tag present, because remember those are bits and they both need to match, right? Update it, right? So let's download this. So temp data is there, is 0, and so it's present, it gets loaded, it's away, it's not, because remember, temp data only, it gets blown up every time, so like it gets deleted. So while this tag is sitting on that reader, then the temp data is getting the serial number. You take it away, now you notice card data 1 is still that data because it's that tag's just not getting overwritten, but the temp data isn't getting updated, and so every time that it's going through, so this is a way that only while my card is sitting on the reader will it give the serial number. And the cool thing about that is you can use what's called user administration in an HMI and tie it to this very tag and give you the option to have pages available or not available, scripts available. Like say you want to have the ability to shut down runtime. Well, I would probably want that for my card only. And so I would put that into the background of like the main page and have a user administration to where only when my card, Mr. Alpha here, like only when an alpha authorized user has their card on the tag reader, would that button that exits runtime, that's the only way it would even be an option. And I could program that using user administration on HMI. Now, I've got a couple of requests for some HMI content about a couple of requests about HMI content about scripting, and because we have this set up now, I'm probably going to do some stuff on user administration. And so the next time that we're on, that's kind of what the plan is going to be for HMIs. And you can kind of think about this concept here of this code reader concept. What I was thinking about doing was taking and making like putting a little card holder on, I realized that was sitting next to the exhaust of my computer, so it's hot. But putting that code reader either on the outside of the little control box, or having a little cutout on the inside to where the metal isn't interfering with the actual reader, and they have like a little card holder that you just take and just kind of set your card down into, and that unlocks all these different features of the machine. And then when I walk away with my card, I pull it away and walk away with it, and then the operator for the piece of equipment has his that or hers and comes up and drops it into that slot, and then it unlocks the ability to run the machine only with an authorized user. And it also makes this say, hey, if your manager or whatever that's on shaft or on shift, all right, I need to change some settings for need to actually change some settings. Well, the operator has to remove his card, and then the manager drops his in, and guess what? All of this would be logged. And so you're logging all of these. Oh, hey, this user logged in, and that's all built into the user administration, because there's a log of saying, hey, user Jason logged in, then manager 1 logged in, and then these settings were changed at this time, and then this manager logged in, and then this operator logged in, this operator logged out, a second operator logged in, and all of that just kind of starts building a story of like, hey, what actually happened? Because if anybody has like ever been in an instance in or worked in a plant, if something goes wrong, nobody wants, the culture in your plant really goes a long way in this, and management has a lot to do with it. Sometimes, hey, it just means it's your job and you're gone, and that's bad. But a lot of times it's like, hey, we just want to know what actually went on. People make mistakes. People do this sort of stuff. We just want to know what actually went on. Well, with this, this type of system makes it like, okay, this person was logged in. We know who to ask what was going on. And if they say, oh, well, I don't know, then you're like, come on, man. Like, we know, and we know that you were there. We don't care that it messed up. We just want to know what happened. And so this is a way that, yeah, it can do this. So next time, hopefully, maybe not next time, maybe another time, but it might be, I'm planning on it to be next time. If I can prepare for it, which this week is a very long week for me, if I can get the HMI content prepared with user administration and everything, we'll talk about that. Otherwise, we might do something about some drives topics that I can just kind of casually talk about with a little less preparation. But anyway, I really appreciate everybody that takes part in this community and takes part in these streams. We hit over 1,100 subscribers to the channel, and I can't thank y'all enough of how much it means to this community and getting this information out and having these live stream comments and chatting back and forth just about what's important to you guys. What are you working on? What are the pain points that you are suffering through at your plant? Because maybe there's not a Siemens solution for it, but maybe there's a Balluff, or maybe a Cognex or a Keyence or some other solution that is out there that in a community like this, we could build up each other and get more and more people tooled up so that when they go out in these more advanced plants with more PLCs and more HMIs and more technology, you're not just completely left out. That's what this channel is for. And if you've made it to this point and you haven't subscribed, I'd request that you consider subscribing, because the more people and the more subscribers that we have in this, the more the YouTube algorithm reaches out, and the more likes, comments. That's the biggest way to support this channel and to get out there. As we start getting more people involved, there will be some more options just with like memberships that I'm trying to figure out. They're like, hey, what would be a good thing that could charge some small amount of a membership fee so that you can kind of get maybe these PLC data types, these projects that we're creating, make them available to the members and things like that. But as we grow, I want to keep all of you guys that are taking part in this growth and this growing community. You're the reason that it's growing. You're the reason that we're doing this, and can't thank you enough for taking part in it. Yeah, so in the meantime, if you're watching this on demand, drop a comment about any questions that you have, and I'll try to get to them. You can't try to get into the chats. It seems like Monday mornings has been the way, or where I've been able to do them for the past couple of weeks. I'd like to get back to doing them on Friday. It's not going to be this week, I can tell you. I will either be traveling or in a plant, starting up a plant. But yeah, drop a like, comment, subscribe. Yeah, keep growing. Thank y'all so much. And until the next stream, y'all keep learning, keep trying, and you can always comment on any of the videos. I try to read all the comments and answer them as quickly as possible. But until then, hope you have a great week, and yeah, just keep learning. I'll see ya.